this idea that GPT-5 can just not only like answer all these hard questions for you, but really create like on-demand, almost instantaneous software. I think that's going to be one of the defining elements of the GPT-5 era in a way that did not exist with GPT-4.
And when I think about our creative process and when I've felt most like I've done my best work, it has required an enormous amount of
you have to sit there and struggle.
And I think that cognitive time under tension is so important. And it's ironic almost because these tools have taken enormous cognitive time under tension to develop. But in some ways, I do think people might say people are using them as a escape hatch for thinking in some ways, maybe. Now, you might say, yeah, but we did that with the calculator and we just moved on to harder math problems. Do you feel like there's something different happening here?
It's different there are some people who are clearly using ChatGPT not to think. And there are some people who are using it to think more than they ever have before. If you give people new tools, in theory, maybe people just work less, but in practice, it seems like people work ever harder and the expectations of people just go up. But certainly for the people who want to use ChatGPT to increase their cognitive time under tension, they are really able to. I mean, there's a lot of other things it's really good at, but this idea of the AI can write software for anything. And that means that you can express ideas in new ways, that the AI can do very advanced things. Of course, it can't do things in the physical world, but it can get a computer to do very complex things. And software is this super powerful way to like control some stuff and actually do some things.
It's about the next stage, what comes after GPT-5. In which year do you think a large language model will make a significant scientific discovery? And what's missing such that it hasn't happened yet?
I would say most people will agree that that happens at some point over the next 2 years, but the definition of significant matters a lot. And the thing that I think is missing is just the kind of cognitive power of these models. A framework that one of the researchers said to me that I really liked is, a year ago, we could do well on like a basic high school math competition. This is something that like the very, very top slice of the world, many, many professional mathematicians wouldn't solve a single problem. And we scored at the top level. Maybe to prove a significant new mathematical theorem is like 1,000 hours of work for a top person in the world. So we've got to go from, another significant gain. But if you look at our trajectory, you can say like, okay, we're getting to that. We just need to keep scaling the models.